Okay, welcome 267 subscribers. One of my classes really wanted to see one of my son's reject sweatshirts that he recently just gave to me. So it's an anime sweatshirt. So I wore it today for you guys. It's really hot in here. I'm about to take it off, but Dragon Ball Z, so comfortable, so fire. So before I start, things are happening. It literally is 500 degrees in here. Okay. So today we're going to quickly review parallelograms and the properties of parallelograms. And then we're going to go into special types of parallelograms. And they're rhombuses, rectangles, and squares. Look at that. Good enough. All right. So here are all the properties of parallelograms. Opposite sides are parallel and congruent. Consecutive angles, they're right next to each other, are supplementary. Opposite angles are congruent. And the diagonals bisect each other. And all the interior angles add up to 360 degrees. Okay, so those are properties of parallelograms. So they apply for all the parallelograms that we're going to learn about today. Starting with the rhombus. So if we take this figure and I move it around, okay, it's a rhombus. What do you notice happens? You see how all the sides stay the same length? Okay, what do you notice? What makes a rhombus special? On the next slide, you'll see the definition of a rhombus. A rhombus is a parallelogram, so all those properties apply. More specifically, it has one more property. All four sides are congruent. They have to have all four sides congruent to be a rhombus, which is why these marks are here for all the sides. So there we go, rhombus. The rhombus has a special property. So if you go ahead and draw the diagonals for the rhombus, and then try to move the rhombus around. You see that? What is happening is the diagonals, not only do they bisect each other, okay, we already know that they do that because it's a parallelogram. More specifically, in a rhombus, the diagonals are perpendicular for every rhombus. So I'm going to write that here. The diagonals are perpendicular. So if you see a figure and you're asked to classify it, and you see that the diagonals are perpendicular, you know it's a rhombus. Slide number 40. How are we doing? Everyone get a blow pop? If you could just get one, that'd be awesome because they're super expensive. But that's 4 bags of blow pops. I want to make sure I have them for all my classes. All right. Moving on to slide number, look at slide 44. So you're asked to classify a quadrilateral, so it has 4 sides, using the most specific name possible. When they ask you to classify, okay, yes, it could be a quadrilateral, it could be a parallelogram, it could be a rhombus or a rectangle or a square. Okay, we have to find the most specific name. Yes, we could say it's a quadrilateral, but what is it more specifically? You can see that the diagonals are perpendicular. So that tells us it's a rhombus. You can also see these angles are bisected. So what that means is this angle is congruent to this angle. So that angle, this interior angle of the rhombus has been bisected, cut in half. Same with this one. This measure is the same as this measure. So this interior angle has been cut perfectly in half. So we can say the diagonals, where's my mouse? there we go, are perpendicular. And the interior angles have been bisected, so it is a rhombus. Good? Rectangle. Here's the next special type of parallelogram. So what is specific? What's another property in order for a rectangle to, or for a parallelogram to be a rectangle? It has to have all angles the same. All angles are congruent, all 90-degree angles. So, on slide 47, we can just say all angles are 90 degrees, or all angles are equal measure. Come on now. Or you could say 90 degrees, whatever. So that's one special property about a rectangle. And there's one more. This figure says classify the figure. Okay, we know it's a rectangle because we're learning about rectangles, okay, but why? See the diagonals. We know the diagonals in a parallelogram bisect each other, right? So this diagonal has been cut perfectly in half, and this diagonal has been cut perfectly in half, okay? But now that we have all 90-degree interior angles, what's happening is these diagonals are the same length. So all these lengths are the same. So we can say it's a rectangle because the diagonals are congruent. Good enough. I love anything but a backpack day. I've seen microwaves, drawers, shopping carts. What else?
Do you see Mrs. Up's canoe?
What?
Do you see Mrs. Up's canoe?
Canoe?
Kayak.
She brought a kayak?
Yeah.
Oh
that's
my
a kayak.
gosh.
There's a blue
That is awesome. Love it. Luggage. What?
Hampers.
Hamper. That's awesome. All right, let's go to squares. A square is a parallelogram with 4 congruent sides and 4 right angles. So it is a rhombus and it's also a rectangle. And what this Venn diagram says is everything in this yellow figure is a parallelogram. So rectangles, squares, and rhombuses have all the properties of parallelograms because they are parallelograms. There's specific types of parallelograms. Just like we had special right triangles, we have special parallelograms. So rectangles have certain properties, and rhombuses have certain properties, and squares have properties that are both rectangles and both rhombuses. I think there's one more slide I want to do. This one. Take a look at it, classify the figure. The most specific classification we can do. So this says that opposite angles are congruent. Opposite angles are congruent. So the sides look the same length, but we're not told that they're the same length. We don't know anything about the diagonals. What do you think it is? I mean, it's got 4 sides. It's definitely a quadrilateral. What quadrilateral has this property? That opposite angles are congruent. Because we don't know anything else besides that. Yep, in fact, if you go back, it's a parallelogram. It's a parallelogram because opposite angles are congruent. And I'm taking you back to the very first slide from today. Where are they? Here it is. The parallelogram review. In order for a quadrilateral to be a parallelogram, opposite sides are parallel, opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent. So that was, we were told. We were told that the opposite angles are congruent. It's a parallelogram. I don't know anything else. Are we good?